Let me do a tutorial of first order homogeneous differential equation. Example number 1. dy or dx equals to x plus y or x. Solution. Step 1. To know that whether the equation is homogeneous or not, multiply the numerator and denominator by a new variable t, which is t times x, t times y, or t times x, which equals to x plus y or x. Because when you take t common from the numerator, it will cancel with the t at denominator, and you're left only with x plus y, which is the exact value of f of x comma y. So it is a homogeneous differential equation. Step 2. Change the equation into f of y or x form. dy or dx equals to f of y or x form. Why we do this? We change the equation in y or x form just for the purpose of simplification to solve it further. Multiply the numerator and denominator by 1 or x. dy or dx equals to x plus y times 1 or x times 1 or x. Just multiply the numerator by 1 or x and denominator by 1 or x. After simplification, I got 1 plus y or x. So that's how I got the equation in y or x form. Step 3. To make the equation into separable variables form, we need substitution. There is some substitution process to follow. Let y or x equals to v. This implies that y equals to v times x. Take derivative on both sides to have dy or dx equals to x times dv or dx plus v times dx or dx. Dx or dx will cancel each other. I have now dy or dx equals to x times dv or dx plus v. So my new equation in step 3 will be x times dv or dx plus v equals to 1 plus v. How we get that? I replace dy or dx by x times dy or dx plus v. I just got it from substitution process here. And y or x by v. Just replace y or x by v. Now v at the left side will cancel with the v at the right side. And my new equation is x times dv or dx equals to 1. Step 4. Separate the variables. Bring x variable at one side and v variable at another side. I have no v variable at left side and x variable at the right side. I just separated the variables. Step 5. Take the integration on both sides. Integral of dv equals to integral of 1 over x dx. Integral of dv is v and integral of 1 over x is natural log x plus c. Now substitute back the value of v, which was y over x, if you remember. Solve it and you will get the final answer, y equals to x times natural log x plus cx. This is the final value. Let me do one more tutorial. Example number 2. dy or dx equals to x to the 3 plus x to the 2 times y plus x times y to the 2. Solution. Step 1. To find whether the equation is homogeneous or not, multiply the numerator and denominator by a new variable t. Do the same process. X cubed by t cubed, x squared by t squared, y by t, x by t, y squared by t squared. I have t cubed here and t cubed here because t squared times t is t cubed. And t cubed here, t times t squared is t cubed. So I have t cubed common among all the three terms. Let me take t cubed common here. When I took t cubed common, I got the exact value of f of x comma y, which satisfies this condition. And therefore it is a homogeneous differential equation. Step number 2. Change the equation into f of y or x form. My new equation will be in the form dy or dx equals to f of y or x. How to do that? Multiply the given function by 1 over x to the 3. I just multiplied my function by 1 over x cubed. After simplification, I got 1 plus y over x plus y over x to the 2. That's how I got my equation in y or x form. Step 3. To make the equation into separable variables form, we need substitution. Do that substitution process. Let v equals to y or x. This implies that y equals to v times x. Take derivative on both sides to have dy or dx equals to x times dv or dx plus v times dx or dx. dx or dx will cancel each other, and I have no dy or dx equals to x times dv or dx plus v. That's how I replace dy or dx by x times dy or dx plus v. And y over x by v, y over x squared by v squared. V at the left side will cancel with the v at the right side, and my new equation is x times dv or dx equals to 1 plus v squared. Step 4. Separate the variables. Bring the x variables at one side and v variables at another side. After separation, I have the v variables at left side and x variable at right side. Step 5. Take the integration on both sides. Integral of 1 over 1 plus v squared is tangent inverse v, and integral of dx is x plus c. Bring the tangent inverse to the right side. Now substitute back the value of v, which was y over x. Just replace v by y or x. Simplify it further. This is the final value. And that's all for the first order homogeneous differential equation.